Hi, in this video, I will be showing you problem number 17 of chapter 8, section 2. The given curve is rotated about the y-axis. Find the area of the resulting surface. X equal to square root of a square minus y square, where y lies between 0 and a over 8. So note there are few things you have to take note of. About what axis the curve is rotated about. So in this case it is y-axis, and also make a note of the wording for surface area. It could be find the surface area or area of the surface. So both mean the surface area is what we are looking at. And the curve, and then you also have to note down whether it is x given as a function of y and bounds for y given or bounds for x given, or if y is a function of x and bounds for x given. So these are the important things that you have to pay attention to so that we can pick the formula that is relevant to the surface area. Recall the two formulas that we did. Surface area rotated about the y-axis. If the curve is rotated about the y-axis, you have surface area equal to 2 pi x ds. If it is rotated about the x-axis, you would use 2 pi y ds, where ds is the formula for the arc length, which is square root of 1 plus dy by dx the whole square dx, or square root of 1 plus dx by dy the whole square dy. So you would pick this one if you know the bounds for x, and you would pick square root of 1 plus dx by dy the whole square dy if you know the bounds for y and if x is a function of y. In our problem, x is a function of y and you know the bounds for y, so we will pick this one for ds. Okay, so ultimately we are going to use integral 2 pi x ds because it's rotated about the y-axis, and then for ds we are going to choose square root of 1 plus dx by dy the whole square dy. So let's start off with finding dx by dy. So x equal to square root of a square minus y square. So derivative of that with respect to y would be 1 over square root of 1 over 2 times square root of a square minus y square, which is the outer derivative, times derivative of the inside, which is negative 2y. So if you cancel out the 2, you get negative y over square root of a square minus y square. So in the expression for ds, we have 1 plus dx by dy the whole square. So 1 plus dx by dy the whole square equal to 1 plus square of this expression, which is y square over a square minus y square. So if you simplify that, it is a square minus y square plus y square over a square minus y square. So which is a square divided by a square minus y square. Then when we take the square root of that, because for ds we have to take the square root of that, so 1 plus dx by dy the whole square, and square root of the whole thing is the square root of this expression. Square root of a square is a, then we have square root of a square minus y square. So coming back to the formula that we have started off with, which is this formula, that S of surface area equal to integral 2 pi x ds, which is integral 2 pi x. X can be written as a function of y from the given expression over here. So I'm going to replace the x with square root of a square minus y square. Then for the part ds, we already found out this expression over here. This is ds. So it is the expression for ds. So we will use that, which is a over square root of a square minus y square dy. So a square minus y square part get cancelled out. So you get integral 2 pi a dy, and then the variation for y is between 0 and a by 8, 0 and a over 8. 2 pi a is after all a constant that can be taken out, and then you have y between 0 and a over 8. So it will be 2 pi a times a over 8. So that will be pi a square over 4. This being surface area, you may want to just say this units square. So a couple of things I'm going to repeat. The curve is rotated about what axis is important, and also whether the function is given as x in terms of y or y in terms of x, whether x is given as a function of y or y is given as a function of x. Then what are the bounds for x or y? Then if you are given the bounds of x, then you may have to choose a formula ending in dx. If you have the bounds for y, and you have to choose the formula that is ending in y. Hope this video helps.